Quartiles and percentiles are ways to separate a set of numerical data into equal parts. As you can recall, the median of a set of data is the middle value. So the median splits the data into two equal parts. Considering this data here, we can find the median by organizing the data in numerical order, which has been done for us, and finding the center value. This center value is going to divide the data into two equal groups of 10. 10 numbers in the first half, 10 numbers in the second half. The median lies between the two 66s. If you take the average of the 66s, you will find that 66 plus 66 divided by 2 will give you your median value of 66. Quartiles divide our group of data into 4 equal-sized groups. The quartiles will divide those two groups of 10 into 2 more groups of 5 each. Our median is 66. Our first quartile is going to be between 64 and 65. Our third quartile is going to be between 69 and 70. Our first quartile is the average of 64 and 65 because it's between those two values. And our third quartile is 69.5, the average of 69 and 70. The range of your data is the difference between the highest value, which is your maximum of 73, and your lowest value, which is your minimum of 53. The range for this data would be 20. The first quartile and the third quartile have a difference of 5. So your inner quartile range would be 5. 1/4 of the data values are below the first quartile. So 25% of your data values are below 64.5. 2/4, or 1/2 of the values, are below our second quartile, also known as our median. So half of our data values are below 66. 3/4 of the values are below the third quartile. So that means 75% of the data values are below 69.5. Take a look at this set of data. Find the quartile values for the following set of data. Go ahead and copy down the numbers, and be sure when copying that you're putting your numbers in numerical order. So we're going to do that now. We're going to organize our data in ascending order from smallest to largest. Here we have the same amount of data as we did in our original. Crossing them off helps us make sure that we haven't missed any data. Now we're going to find the median, or the middle. In order to do this, we have to count how many total values we have. We have 14 total values in our data set. So we have 2 groups of 7 if we're going to split it down the middle. So if you count 7 from the left, 1, 2, 3, 4, 5, 6, 7, and 7 from the right, 1, 2, 3, 4, 5, 6, 7, we end up on the values of 8 and 9. Our median is between 8 and 9. So our median is going to be the average of 8 and 9, which is 8.5. Now, in the groups of 7, we need to find the middle to find the quartiles. On the left-hand side, we can split our data group into two halves with 6 being in the center. 6 would be our first quartile. In the upper half of the data, we can split our data groups into 2 equal groups of 3 with 12 being in the center. This would be our third quartile. Using this information, we can create something called a box-and-whisker plot. A box-and-whisker plot displays the spread of the data on the number line. This will be helpful in determining how many values are above or below a certain number, whether it's your first quartile, your second quartile, also known as your median, your third quartile. You can also see your maximum and your minimum on this box-and-whisker plot. The lowest value of our data set is 53. That's our minimum. Our first quartile we found to be 64.5. So we'll place that as well. Our median we found to be 66. Our third quartile we found to be 69.5. And our highest value, also known as our maximum, we found to be 73. So we will place dots on all of these important pieces of information. We're going to put a box around the first and the third quartile and a line through the median. Hence the box part of a box-and-whisker plot. The whiskers are going to extend to the high and low values from the first and third quartiles. This is what we call a box-and-whisker plot. You can see that the range of your data, or the spread, goes from 73 to 53, so it covers 20 values in between. That's your range. You could also discover your inner quartile range from your box here. Your third quartile is 69.5. Your first quartile is 64.5. So you know that 50% of your data is between 69.5 and 64.5, or has a spread of 5 values. A quarter of the values in your data set are in each section of a box-and-whisker plot. Between the lowest, which is 53, and the first quartile, that's 25% of the data. Between the first quartile and the median, that's another 25% of your data. The median and the third quartile also contain 25% of your data. And between the third quartile and your maximum value will contain 25% of your data. A short section between 64.5 and 66, between 64.5 and 69.5 means that your data is dense or that it is clustered. A long section means that your data is spread out or scattered. There are 5 numbers that represent a statistical summary. Those are the values that we plotted in our box-and-whisker plot. The minimum, the maximum, the first quartile, the median, and the third quartile. You can also divide your data into percentiles. Percentiles are important in ranking. You often see them when you get SAT scores that are comparative to other people taking a test. The percentile rank of a score is the percentage of scores that are at or below a particular value. These are used to tell what percent of the total values are less than or equal to a given value. So for instance, if you are taking the SAT exam, you're being compared to other students taking that exam. So whether or not you score well, if you score better or in the 80th percentile, that means you scored better than 80% of the people taking that exam. For example, if 400 students took an exam and a score of 75 was the 65th percentile, that means 65% of the students taking the exam scored at or below a 75. To find how many students are at or below a 75, you would take your percentile and multiply it by the total value in your data set. There were 400 students, so we'll multiply 400 by 65% in decimal form to get 260. That is how many people scored at or below a 75 on this exam. 35% then scored above the 75. So we know that 140 people scored above a 75. Given this data set, what score is the 40th percentile? We have 20 total scores. So the first thing you want to do is count how many data values you have. Then you're going to multiply that by the percentile. 20 times 0.4 is going to give us 8. So we are going to count from the bottom to the 8th score. So go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8. 65 will be the 40th percentile because that is the 8th score from the. Taking a look at 75, what score is the 40th percentile? Now we added a score. So now we have a total of 21 total scores. So again, we're going to multiply our total scores by the percentile, and we're going to end up with a decimal. You need to include the whole score above 8 to include the scores less than or equal to that value. So now we're going to use the 9th score, which is going to be a 66. So 66, once we add that 75, is going to be in the 40th percentile. You can also do this based upon a table. Can you find the interval that contains either the upper or the lower quartile? To figure out which values would be the quartiles, you need to take a look at your total frequency. Your total frequency is 32. So if you were going to look at the upper quartile, quartile meaning quarter, you need to find a quarter of 32, which is 8. So you're going to count 8 from the top interval. Our top interval here is 91 to 100. That contains 6 scores. That does not contain the 8th score, so you're going to have to move to the next interval, which is 81 to 90. So the upper quartile is in the 81 to 90 interval. To do this again with the lower quartile, we're going to take 25% of our total frequency, which is 8, and we're going to count 8 from the bottom. We have 3 in our lowest interval, which does not include the 8th score. We're going to jump up an interval, which contains 0 for a total of 3 scores, still not at 8. We're going to jump up another interval to the 61 to 70 range. That contains a total of 7 scores at or below that interval, so we're still not at the 8th score. So we have to jump up one more interval, so our lower quartile will be in the 71 to 80 range.